Okay, now let's try a harder example. And this time it's an example where we're forced to use the tape to record state and not just use the states of the Turing machine itself to like remember something. Using, this should really be tape as memory, sorry. Memory. When we only have like one of two things to remember, we can just encode that in the states. But if we have like an arbitrarily large amount of data to remember, we can use the tape itself to record things that we wish to remember. And because the set of tape symbols can be larger than the set of input symbols, if we need to separate things on the tape, we can always just come up with a new arbitrary symbol like a $ or a hash to do so. So the problem we're given is to convert a number from unary to binary. So that basically count the number of ones on the tape and then replace whatever's on the tape with a number in binary representing the number ones that was originally there. Okay, so first let's talk about the rough sketch of the algorithm. So if I have some number on the tape, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, the algorithm that we're going to do is that the first thing we're going to do is we're going to record the count of how many ones so far, and we're going to separate it using another symbol like a hash. So we want to put a hash to the left of the input string, and then write a 0. So this will be the count of the number of ones, and this is the number of ones left to count. So what the Turing machine will do is it will fly to the right-hand side, it will see the first one, it will delete it, move all the way to the left, and then increment this number by 1. So this will now become 1. Go back to this. It'll go back to the other string, find the last one, delete it, increment this number, 1, 0. 1, 1. 1, 0, 0, 1, 0, 1, 1, 1, 0, and then when there's no more ones to count, i.e. past the hash there's only ones, we can then delete the hash. And there we go. So that's going to be the rough algorithm we're going to follow. Let's sketch out the Turing machine to do that. Okay? So I'm in S0, and I see some ones on the tape. We'll ignore the edge case of the string being empty, so we'll say there's at least a single one. So the tape head always starts pointing to the left. So if here's my string, I start pointing to the left. So I'll step to the left and put a separator. So if I see a 1, which I know I will, write a 1, step to the left. Okay, so now I'm pointing here at a blank space. Place the hash symbol. See a blank, which I know I will, write a hash, step to the left, put a 0 here, see a blank, write a 0, move right, okay, and then move right again. So see a hash, which I know I will, write a hash, move right. So this is just like setting everything up. And now we can do an algorithm. So I want to go, so really this can go all the way down to like the real Turing machine. So this is just setting things up. See a hash, write a hash, move right. Okay, so the first thing I want to do is zoom all the way to the right hand side. So while I see ones, move to the right. Zoom all the way to the right I go. And then as soon as I see a blank, put the blank back, take one step to the left. See a blank, write a blank, move to the left. So I'm going to go 1, 1, 1, blank, move to the left, and now I'm pointing at the last one. Well, now I'm pointing at potentially the last one. So, okay, if I see the 1, then I delete it. And then move to the left, and then rewind all the way to the start again. So while I see ones, keep moving left until I hit the hash. And then take a step to the left. And then I'm going to increment this number. So now I can just like insert my adding machine from before. So here's my adding machine. I can just like take this whole thing and just shove it in here. So I have this like a subroutine. If I was being pedantic, I should like explicitly draw this thing out. So this machine will like sneak in here, and this will no longer be a halting state. So we know how to add binary numbers, so let's suppose we've done that. Suppose the binary number is added. Then we want to rewind the tape back to the hash. So, once the adding machine is done, go to S6. See a 1 or 0, doesn't matter. Just keep moving right till we see the hash. And then I want to move to the right. So now I'm pointing back here again. And so now I'm going to check if there's any more work to do. So if I see a blank, that means my work is done. I should delete the hash and then stop. So I see a blank, move to the left. And then delete the hash and then hold. And move left and then hold. Otherwise, if I see a 1, there's more work to be done. So then I should go all the way back to here. See a 1, write a 1, stay, and then zoop back to the start. Okay, so let's try running this. So I'll make a little tape here. Okay, I'm going to count 1, 2, 3 many ones on the tape. Okay, so let me get some more chess pieces because am I going to have enough? No, I'm going to need some more. Alright, here we go. So the tape head starts on the left. If I see a 1, write a 1, move left. If I see a blank, which I know I do, write a hash. I guess I'll use this coin to represent a hash. The coin is shiny. I'll use the cardboard. There we go. So the cardboard represents a hash. And then see a blank, write a hash, move left. See a blank, write a 0, move right. And now I'm in S3. See a blank, write a 0, move right. S3. See a hash, put the hash there, move right. So now I'm in S3. There's 2 S3s. We'll call that S10. Alright, so we start here. See a 1, write a 1, move right, move right, move right. See a blank, write a blank, move left. See a 1, delete it, move left. And then we keep winding till we get to the hash. See a hash, write a hash, move left. And then we go to the adding machine subroutine. So let's see what the adding machine does. See, so basically that's moving to the right hand side of the string. I'm going to have to edit this, so if it sees a hash, it writes a hash and moves left, so it works for our machine. See a hash, write a hash, move left. If I see a 0, replace it with a 1, stay, and then transition to the state H. So instead of H, we're going to leave the adding machine and go back to S6. Alright, so see a 0, write a 0, move right. See 1, write a 1, move right. And then when we see a hash, move right again. So we rewind back to the hash. And then take a step to the... So see a 1, write a 1, move right. See a hash, write a hash, move right. And then back to S7. So now I see if there's any more 1s to delete. So there are, in fact. So we see a 1, rewind of 1, we stay, and we go back to the start over to S3 again. So rewind to the left, see the blank, move left, see a 1, delete it, move left, rewind, see the hash, write a hash, move left, run the adding machine, so it'll flip this to a 0, step to the left, and then this becomes a 1, and then rewind, delete this, go back here, run the adding machine again, go back here, see a hash, write a hash, move right. So after all said and done, we run that a few times, we're going to be in S7 again. See a blank, write a blank, move left. See a hash, write a blank, move left. So we turf the hash, move left, and then we finally stop. So what we initially had on the tape was 3 1s. What we had on the tape afterwards was 2 1s representing 1 1 in binary, which is the number 3. Okay? So it's a pretty convoluted machine, but you can see it's made up of simpler parts. There's a part here that sets up everything, that writes all the special separating symbols. There's a part here that rewinds to check if there's more work to be done. There's a part here that deletes each of the 1s, and then this part here is our adding machine that we did before. So that's how you design a Turing machine to convert a number from unary to binary. And if you're formally writing this out, you probably should explicitly include the adding machine part here, and then you can sort of like draw a little box around it and indicate that's what this part does.